I think when I ask you this on your test, I'll break it up into different pieces. So I'll first say, instead of saying just sketch the graph, my first question would be like, what is the domain? And then anytime we're finding domain, we're looking for two things, right? Is there a 0 in the denominator, or is there a negative under the square root? Those are the two things we worry about. In this case, we can set the denominator equal to 0. So 1 minus x squared is not allowed to be 0. So this means that 1 minus x, 1 plus x is not allowed to be 0. This means that x cannot be 1 or negative 1. Right? The second question might be, what is the y-intercepts? To find the y-intercept, you set x equal to 0. So then we got y is equal to 0 squared over 1 minus 0. That's equal to 0. So your y-intercept is going to be the point 0, 0. Right? In fact, what does it mean when you have a 0 in the denominator, like we did over here? What did this tell us about the graph? Because once you see you have zeros in the denominator, you kind of know that you have a certain type of asymptote, I think, right? So I'll just mention. So this means that x equal to 1 and x equal to negative 1 are vertical asymptotes. Okay. So I got distracted. I still need to find the x-intercepts. So for the x-intercepts, how do you find those? You set y equal to 0, and then you solve for x. So you got 0 is equal to x squared over 1 minus x squared. Anytime you have a fraction that's equal to 0, that means that the numerator is equal to 0. So that means that x squared is equal to 0, which means that x is equal to 0. So what we see is that the x-intercept and the y-intercept are the same point. They're both 0, 0. The last thing we want to do is we want to check the end behavior. So I want you guys to do this part. I want you to calculate the limit as x goes to infinity of x squared over 1 minus x squared. Take a couple moments to do that, please. And then let me know when you're done and we'll move on. So what did you multiply top and bottom by? Anyone want to tell us in the chat box? Good, for sure. So we're going to multiply top and bottom by 1 over x squared, because that's the highest power that lives inside the denominator. And when we do that, what do we get? We're going to get the limit as x goes to infinity, 1 over 1 minus 1 over x squared. This is a situation where the top is a constant and the bottom gets bigger and bigger and bigger. So this guy goes to 0. So then you just get that's equal to 1. So this means that y equal to 1 is horizontal asymptote. We get the same if x approaches negative infinity, right? Like nothing different is going to happen. So even if x goes to negative infinity, this still goes to 0. So in the end, from both directions, you get this, this situation. Is there any questions about the first three parts here? All right. So at this point, I'm going to try to draw a sketch of what we've got so far. So we have one point, which is 0, 0. Oops. That's both the X and the Y intercept. We got a vertical asymptote at 1. So maybe I'll do my vertical asymptotes in green. Normally I do it dotted, but I want you to be able to see it. So I don't even know if you can see that. Well, there's the one at 1, and here's the one at -1. 2 vertical asymptotes. Can you see that? It's hard to see. Purple, pink, pink, pink. Fuchsia, whatever color that is, that looks better. You see the vertical asymptote there, right? We should label those. So it's going to be X equal to 1, and this is X equal to -1. And then we should do the horizontal one. So the horizontal one was Y equal to 1. So this guy looks like this. This is Y is equal to 1. Okay. Makes sense so far. So we kind of have this framework here. This is sort of like the skeleton of my graph. And then my graph, who knows what my graph looks like? Let's just for fun, imagine the possibilities. I'll do it in broad strokes in purple. You know, it could go like this, right? Go, and maybe it goes like this. Maybe go like this. I don't know. Maybe it doesn't look like that at all. Maybe it goes. I have no idea. Maybe it goes. I don't know. But I'll be able to answer all these questions once I do steps 4, 5, and 6. Or I guess we already did 4. What is 4 again? Find the vertical asymptotes. Yeah, we did that. It's kind of combined with the domain, actually, right? Because finding the vertical asymptotes is saying the denominator equal to 0. That's the same thing as finding the domain. All right, so now we're at the derivative part. So the derivative part is the best part, right? So I want you guys to take a second and calculate the derivative of f prime. So remember that the quotient rule is f prime g minus g prime f over g squared, right? So in this particular case, that's going to be 2x times 1 minus x squared minus g prime is negative 2x times x squared times f, which is x squared, all divided by the bottom squared. The bottom squared is 1 minus x squared, quantity squared. This time we do need to simplify it because we got to take a second derivative later, right? So I would leave the bottom as it is. But the top, we want to expand that. So this is going to be 2x. We got to distribute. This will be minus 2x cubed. And then this last term will be plus 2x cubed. So that worked out really nicely because the 2x cubes cancel out. So you end up with this relatively simple looking derivative 2x over 1 minus x squared squared. Did you guys calculate the derivative correctly? I'm just curious. It's been a while since you did the quotient rule. Word you forgot. Okay. Look, one of the reasons why I went and did integration next, and then I came back to do applications of derivatives is because I want you to review trying to take derivatives again. So it's been a while since we did this quotient rule. So I'll give you another chance to practice really soon. Before then, we really need to identify the critical points. So remember, the critical points are going to be where the derivative does not exist or is, that's when either f prime of x is equal to 0 or f prime of x does not exist. So in this particular case, what are the critical points that we have? You can look at that derivative and tell, I think. What would you say? 0 is for sure 1, because that's where the derivative is 0. Where does the derivative not exist? When is the denominator 0? Yeah, 1 and negative 1, both of those. Okay. So, so if you recall last class, I kind of taught you a couple different ways to do the increasing, decreasing information. So let me just refer back to it. This first way I showed you is with test points, and a lot of students like to use test points. The second way that I showed you used a table, which I like, but my students seem to not like. So there's certain instances where the table way is superior, in my opinion. And this is one of those times, right? I only care about the sign of this derivative. I don't really care about the actual values. So, so I think I can use a table to solve this. Okay. The only question is, where do I put my table? I guess I'll squeeze it in on the left over here. So let me try to do this in a way you can read. So along the first column, I'm going to put each of my factors. My factors are going to be 2x. That's the first factor. And the second factor is going to be 1 minus x squared squared. Those are the two factors that I worry about. And when I put those together, when I multiply those signs together, that's going to give me the sign of f prime, which is my goal. So I put f prime at the bottom. Now I want to take these critical values that I just had there, and I want to break my domain up into different sections, just like I did in the other way. So I'm going to go from negative infinity to -1. I'm going to go from -1 to 0. I'm going to go from 0 to 1. And then I'm going to go from 1 to positive infinity. Okay. And look, 2x, it's really easy to find the sign of 2x, right? It's positive when x is positive, and it's negative when x is negative. So I could just put a plus here and a plus here and a minus here and a minus here. Does that make sense? And what do you notice about the sign of this guy? What happens when you square a number? What does that do to the sign? Let me change the captions. Hold on. All right. That's right, Benny. It's always positive. So I could just put plus, 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 plus here, right? So in the end, a negative times a positive is a negative. A negative times a positive is a negative. A positive times positive is positive. Positive times positive is positive. So what do I know? I know it's going to be decreasing, then it's going to be increasing, then it's still decreasing, then it's increasing, and then it's increasing. Is there any questions about that? All right. Now I want you guys to calculate f double prime. So f prime is over here. Use the quotient rule again. Take the derivative of that guy. All right, let's take a look at this. So we still need to use the quotient rule. So this guy up here is F and this guy down here is G. And you take the derivative at the top, you're going to get a 2. You keep the bottom thing, which is 1 minus x squared squared. And then when you take the derivative of the bottom thing, you got to use the chain rule. So the derivative of the bottom is going to be 2 times 1 minus x squared times the derivative of the inside, which is times negative 2 x. You got to keep the multiply by the top thing, which is 2x like this. All divided by the bottom squared. The bottom squared here is going to be 1 minus x squared quantity to the 4th power, because we're squaring the bottom. Is there any questions about this second derivative, first step? Did you guys manage to get this part right so far? Okay, good. Makes me happy. We're not done because we got to factor this. So here comes a fun part, friends. So I noticed that I have a 1 minus x squared and a 1 minus x squared there. So I can pull that out, right? So I pull that out and I'm going to get what? Get 1 minus x squared. And that's going to cancel with one of the 1 minus x squareds on the bottom. Okay. So then what do we have left? Well, there was still a 1 minus x squared left there. Maybe I shouldn't skip any step. Maybe I'll just write it again. So here's 2 1 minus x squared. So that was still there, right? Because we only factored 1 out. And then what about the rest of this? I'm going to multiply the rest of this together. So we're going to have 2 times 2 times 2 is 8. But then a negative times a negative makes it positive. So this will be plus 8. And then you got x squared times x times x, which gives you x squared, right? This is divided by 1 minus x squared to the 4th. Is there any questions about that step? All right. Then we can simplify a little bit because 1 over x squared is going to cancel with one of those 4 in the denominator. And then I can simplify the numerator. So this is going to be, I just distribute the 2, that gives me a 2 there. And I'll have a negative 2x squared plus 8x squared. That's going to give me a plus 6x squared. So in the end, my derivative looks like this. Is there any questions about this so far? Did you guys get this as your derivative? Yes. Maybe. Maybe not. Somewhat. Okay. So we want to see where the derivative doesn't exist and where the derivative is equal to 0. Is this numerator ever equal to 0? I don't think so. You could try to factor it. You know, I mean, if you try to factor it, you could pull out a 2, and you get 1 plus 3x squared, right? But it's never going to be 0. Why? Because when you look at that guy, it's like an x squared graph. then you do a vertical stretch, and then you shift it up by 3. 1, 2, 3. So it's shifted away from the x-axis. So it's never going to cross the x-axis. So it's never going to be 0. So that numerator is just never 0. The denominator, though, does have some issues. So the denominator is going to be, really, you could write it, we could factor it just like we did before. You could get 1 minus x quantity cubed, and then 1 plus x quantity cubed, right? So to me, it looks like the possible inflection points are x equal to -1 and 1 again. Okay. So we are going to create our little table again. On one term, we're going to have a 1 minus x cubed, a 1 plus x cubed, and then a 2 times 1 plus 3x squared. And this will be a negative infinity to -1. This will be -1 to 1. And this will be 1 to positive infinity. And somehow I've run out of room here. Let me move this. All right. This will be our f double prime. Okay, so when you look at this guy, the cubes aren't really going to change the sign, right? Like if it's a positive number and it's cubed, it stays positive. If it's a negative number and it's cubed, it stays negative. So we don't have to worry about that. We noticed that, you know, if you just imagine plug in like a -2, you're going to get a positive number in here. So it's going to be positive, right? This guy, you plug in a 0, it's still going to be positive. You plug in a 5, that's going to be a negative. If you think about it, that makes sense because 1 minus x looks like this. The slope is negative. So it's going to cross the x-axis and then become negative. If you look at the next guy, you know, you plug in a 0, it's positive. You plug in a 5, it's positive. You plug in a -2, it's negative. And then for the last guy, this one's always positive. I talked about this, the shifted quadratic, so it's always positive. So in the end, you're going to get a negative, a positive, and a negative. Negative things make you sad, so it's concave down, then concave up, and concave down. Is there any questions about the second derivative test or the test for concavity? Now we want to put these two situations together. So the important points that I have are, I go from -1 to 0 to 1 like this. Okay. It's decreasing in concave down. So this guy looks something like this. Then it's decreasing in concave up. So that looks like this. Then it's increasing in concave up. So it looks like this. And then it's decreasing and I'm sorry, it's increasing, but concave down. So it looks like this. Any questions about that? Because now I want to fit these curves onto this framework. Okay. All right. So I want you to imagine that I took this piece right here and I want to fit it right here. in this, on this side over here, where it's supposed to both hug this horizontal asymptote, but it also has to hug this vertical asymptote, and it has to be decreasing, and it has to be concave down. Can you guys see it's going to look something like this? So when I go to graph this guy, I think comes something like this. Wait, I have an issue. Oh my God. Wait, did you guys see what happened? Do you guys see what happened over here? You see what happened over here? This guy. Okay, let me backtrack. Let me tell you what happened. I mean, I'm gonna fix this in a second, but I was looking at this picture right here, and I'm like, hey, look, this is supposed to be decreasing and concave down, right? So I was about to draw this picture right here. It's decreasing, it's concave down. I was all set to show you this, something like this. When I draw this curve, what happens? It has to cross the x-axis somewhere, right? But when I go in to find the intercepts, I only found one x-intercept. That means something went wrong. And what went wrong was I calculated a horizontal asymptote incorrectly. So do you guys see what I did incorrectly? Because I have to fix it. No, okay. When you distribute the bottom, the first term is 1 over x squared, and the second term is -1. So that means that when you take the limit, this part goes to 0, but it's 0 over -1. So my horizontal asymptote is actually y equal to -1. So this is y equal to -1 like this. So when I went to graph this line, this y equal to 1 line, it was y equal to -1, not y equal to 1. So we're never going to cross the axis there. So I think there's a lesson there that I need to learn, I guess. So let me just shift this whole thing down. And let me rewrite this as a y equal to -1. And then I can just redraw my curve, but this time I can see, oh, there is no issue. We never cross the x-axis. It goes something like this. It goes, oops, it goes, that's to hug each of those asymptotes and kind of match this general shape. Oh, yeah, sorry. Sorry, Christy and Catherine. I tell you how I'll make it up to you. I'll post these notes to Canvas, so then at least you'll have a working copy that you could look at any time. How about that? Yeah, that's not, doesn't make you feel great. Sorry. So now let's look at the next part. The next part says, you know what? You're gonna have a min at 0. So the minimum is at 0. It's got to be decreasing and concave down, and it got to switch to increasing and concave up. I think it can only really look one way. It's gonna look like a U, where the bottom of the U is at the origin. This guy comes like this, comes up like this. Okay. And then the last part, it has to be increasing and concave up. It's probably a mirror image of this graph. So of the left-hand side of the graph. So maybe it looks something like this. Roughly something like that. Left side looks better than the right side, to be honest, but you get the right idea.